We're going to have a look at the merge sort. So if we begin on line number 12, we begin with the importing the arrays class, and that just simply allows us to access arrays methods such as the toString method. If we jump straight in, we've got the merge sort class, and inside we have defined two arrays at this class level. This is probably not the normal way to approach it, but I decided to define an array at the static class level and a helper array at this level also, just to rather than having to define it within the merge sort or within the main method, I can reference it simply at the class level and I don't have to define a new helper array later on. So this just made things easier for me. We move down to the main method, and if we look at the main method on line 21, we are simply printing out the array using the array toStrings method. This is going to be in its unsorted format. We move down to line 22, we conduct the merge sort, and after the merge sort, our array will be sorted in ascending order, and then in line 23 or on line 23 we again call our array and we print it out, and this time it's going to be sorted in ascending order, being 3, 5, 43, 86. Now let's just get into it and have a look at the merge sort firstly. So if we have a look at the merge sort receives two values. It receives a low and a high value. Now these values essentially represent the starting point of our array, which is 0, and our length minus 1, just to stay within the boundaries. So that is, as you can see, the arguments given on lines 22. So that's going to be 0 for our low and 3 for the high. Now when we come in, we have our base case test, and the base case simply just says if low is less than high, and this simply allows us to stop our recursive calls and stop us going into an infinite loop. So is 0 less than 3? Yes it is, so that allows us to go to the body and continue. Obviously when those two figures match, because they're halving each time, so if 0 becomes the low and 0 becomes the high, then 0 is no longer less than the high because it's the same as, and that will allow us to stop. So if we look at line number 29 here, what we can see is that we are saying we are defining our middle position. Now if we consider that the approach to this merge sort is simply halving our search area, or our sorting area, each time, it means that we are simply cutting our array into 4 sections. We start off cutting it 86 and 3, so that becomes our low section. 43 and 5 become our high section, and then we have 86 and 3, so 86 becomes the low and 3 becomes the high, and then after we conduct our merge. So this obviously allows us to operate in a parallel kind of way. So low plus high, which is 0 plus 3, divided by 2, and just remember this is integer arithmetic, so we're going to return 1, and then our low point is going to be 0, our middle point is going to be 1, okay, and for the second half it's going to be middle point of 1 and middle point plus 1, so that's going to be 2, 0, 1, 2, and our high point is going to be 3, okay, and then we have our merge. If you look at the diagram that I've pasted to the right, it shows you the way that the calls will occur. So essentially we start off with 0 and 3, then once we break it down, this is going to go to 0 and 1, and we will plug those values in, so 0 being the low and high being 1 for the first half of the array, because essentially we're breaking down our array elements into subsets and smaller subsets till they're individual. Once they're individual, then we arrange them according to the merge. So if we check out this diagram, you can see that we have our first call of merge sort is 0 and 3, and then on the left hand side it breaks down into a tree essentially. We have 0 and 1, which is the first part of the tree, the lower part of our merge sort, and then that breaks into two components recursively: merge sort 0 0 and merge sort 1 1. So merge sort 0 0 is 0 less than 0, no, so then it stops at that point, and is 1 less than 1, no, that also stops at that point. So then we go to the merge call and we have 0 0 1, which essentially is going to be 0 for low, 0 for middle, and 1 for our high. Now, how do we get 0 for middle? Essentially it's going to be our 0 plus 1 divided by 2. Now 1 divided by 2 is going to be 0.5, but because we're doing integer arithmetic, we're going to get a 0. So that's why we have our middle point as 0, and our high point being obviously our highest element, which is the 3, so that is 1. Okay, and you can see that once we complete our merge, from the merge explanation, we return with our elements sorted. So essentially the first step is to pass our values to the helper array, because currently our helper array will have just the length of the initial array, but it will have no values in. So at this point we copy our values over and we are running up to the first position. So I is going to be equal to our low, which will be 0, and high will be equal to our 1. So essentially this is around 2 iterations, and that will fill our helper array with 86, 3, and the subsequent elements will just be 0 0. We come down to our indicators, or our index points here, and these indexes simply allow us to fill the array accordingly. So this is like a swapping algorithm. If we have our first element I being less than our second element, then we go with the first argument. If we find that our first element is greater than our second element, then we go with the else statement. And then the final while loop allows us to fill the remaining position. So let's just run through it. So we have 86 and 3. So while I is, and if we remember, our I is currently at 0. If 0 is less than or equal to middle, yes, we know it's less than our 1. And J, okay, which is our middle point, is less than or equal to high. Now we know that it's going to be equal to, so that allows us to go to the body. So when we get to this point here, line number 48, it says, it looks at our helper array, which currently has 86 and 3, and it's simply arranging the elements now. So it says, is the first element essentially less or equal to the second element? Okay, so is 86 less than or equal to 3? Okay, 86 is not less than 3, so obviously we're going to skip this statement here, and we're going to go to the else component. So as we know, 86 is greater than 3, so what do? We simply say take the helper value J, which is our first position here, and we want to fill it into our original array, and we want to place it in position 0. Okay, so currently our array looks like this. Let me just check: 86, 3, 43, 5, 86, 3, 43, and 5. So that's our numbers K array. Okay, and essentially what happens here, we're going to take the J position, which is position 1 here, and we're going to say take your value from the helper method here, which is the 3, and we're going to place it in K, which is the 0. So we're going to essentially amend our existing original array, and it will be 3, 3, 43, 5. Now at this point, j increases by 1, so that now becomes 2. So when we run back through the array, we see I is less than, okay, sorry, we also need to increase k by 1, sorry. So we increase k by 1, so that now becomes 1 rather than 0. So then we come back around in our while loop, and what does it say? Will that happen after? Perhaps that happens after, because our body is here. Okay, so perhaps that happens after, no issue. Okay, so we run back around and we say I is less than or equal to middle. So now I remains at 0. So is 0 less than or equal to middle? Yes, it is. But j has increased to now 2. Is 2 less than or equal to high? No, it's not. So that means now that we've terminated this while loop, and then k increases by 1. So that goes up by 1. And then we come to this component of our next while loop. Now this simply says while, and that's I is less than or equal to middle. So if we remember I, we just substitute our values, is 0. And while it's less than or equal to middle, so is 0 less than 1? Yes, it is. So is 0 less than or equal to 1? Yes, it is. So we go to the body, and now simply we are swapping out our other element, which is our position 1 here. So what does this line say? It says helper I. Now we're looking at position 1. Oh, sorry, position 0 in our helper array. Okay, so position 0 in our helper array, and we're going to assign that value to position 1 in our actual array, so our numbers array. Alright, so I'll just write that down. So simply 1, so numbers, I'll fill the values in to begin with. Numbers 1, box bracket, which is in reference to, I'll do that in a second, is equal to now helper box bracket 0. Okay, so if we think about what those values are, helper 0 contains our value 86, and numbers 1, as you can see up here, originally contained 3. Okay, but now we're going to rub that 3 out, and we're going to put 86 into that box. So now our array is going to be amended to 386, and the rest continues as it was. Okay, so that's an understanding of what's happening here. So essentially this sorts out the first element, it puts it in the correct order, and then this replaces the subsequent element, okay, depending on where and what our position was in the array. Okay, so again, as you can see, this component is quite important.